Broadly speaking, any chemical substance which does not bear metallic properties like low conductivity of heat, high volatility are considered as nonmetals. Solid minerals generally have no luster since they cannot reflect light. They may be brittle, that is, they can be broken into pieces when hit. They are generally non-malleable and non-ductile. Hence, they cannot be flattened or turned into sheets or wires or given a necessary shape. Non-metallic minerals are minerals that occur naturally on the surface of the earth and are used where the utilization of heat and electrical transmission are neither wanted nor required. There are some non-metallic minerals used in the industries of refractory, chemical, cement, and gemstone, to name a few. Common examples of non-metallic minerals are marble, clay, salt, and sulfur and nitrogen are used in the industry of fertilizers. The complex nature of non-metallic minerals is dependent on the composition and the properties of the components of which they are made. Non-metallic substances can vary from being expensive, example gemstones, to inexpensive rocks or gravels, which are useful substances that are utilized in the construction of building or roads. Non-metallic resources are higher in volume than metallic ores. Manufacturing units from around the world are almost totally dependent on the non-metallic substances for their functioning. This is because, owing to their properties, they can be used in a wide range of applications. As these are naturally found in different areas in varying quantities, there is an ongoing international trade of non-metals. Difference between non-metals and metals. Non-metallic substances are very different from metallic substances in terms of intrinsic properties. In order to understand the physical differences, it is important to first know the differences in the chemical properties of metals and non-metals. Differences in chemical properties between metals and non-metals. While metals have 1 or 2 electrons in their outer shell, non-metals have 4 to 8 electrons. While it is easier for metals to lose their valence electrons, non-metals easily gain valence electrons. The oxides formed by non-metals are acidic, in contradiction to the basic oxides formed by metals. Non-metals can be good oxidizing agents, while metals are good reducing agents. The electronegativities of non-metals are higher than those of metals. Differences in physical properties between metals and non-metals. Metals are good conductors of electricity as well as heat, as opposed to non-metals, which are poor conductors of electric and thermal energies. Unlike metals, non-metals are non-ductile, that is, they do not have the physical property to be stretched into thin wire. Non-metals are generally transparent or translucent like thin glass, and metals, on the contrary, are opaque. Non-metals are unable to reflect light. Hence, they lack the luster of metals. At room temperature, all metals apart from mercury are in solid state, whereas non-metals can exist in solid, liquid, or gaseous state at room temperature. These chemical and physical properties of pure metals and non-metals are manifested in the properties of the metallic ores and non-metallic substances, setting them apart. Non-metallic minerals consist of different compositions of substances whose properties culminate to give special features to the different non-metallic substances. Types of nonmetals. As chemical substances, there are 22 different nonmetals that are known to exist in the modern periodic table. These include even noble gases. Industrial nonmetallic minerals, which are made up of these substances, can be grouped largely into three main categories. They are igneous, sedimentary, and metamorphic. Igneous rocks. These are formed by the cooling and solidification of molten magma on the Earth's surface. Examples of nonmetallic minerals formed from this kind of rock are granite, dolerite, basalt, etc. Sedimentary rocks. These are formed by deposition or sedimentation of substances eroded from pre-existing rocks or minerals at the bottom of seas or lakes. Clay, sandstone, and limestone are well-known examples of non-metallic minerals formed from this kind of rock. Metamorphic rocks. This kind of rock is formed when either igneous or sedimentary rocks are subjected to tremendous pressure and heat. Under the lithostatic pressure and thermal alteration, their properties, both physical and chemical, change or get metamorphosed completely from those of the original rocks. Primary properties of industrial nonmetallic substances. Nonmetallic substances are widely used in different types of industries like refractory, fertilizer, cement, chemical, gemstones and construction based on their properties. Refractory. Substances that can retain strength at high temperatures are used for the purpose of refractory. The chemical and physical properties make them perfect for use in such systems where there is a chance of exposure to temperature higher than 1000 degree Fahrenheit. They are used in the linings of reactors, kilns, furnaces, crucibles, and incinerators. These substances have physical and chemical stability at high temperatures. They have resistance against thermal shock. They may be chemically inert. Different nonmetals have different thermal conductivities and thermal action coefficient and must be chosen accordingly. Fertilizer. Nonmetals are used in fertilizers. Due to repeated use of soil for agriculture, the soil runs out of some of the major non-metallic nutrients needed by the plant. Non-metallic substances which are important for the health of the plant are used in fertilizers so that they can lead to the increase in the yield of crops. These nonmetals are capable of being directly absorbed by the plants and they provide direct nutritional values to the plants. They are able to add indirect nutritional values in the form of soil amendments, example, sulfur in saline alkali soils. They are able to form compounds with each other or with other pre-existing minerals to be able to increase the efficiency of themselves as well as the others. Cement. Cement industry, one of the most important and in-demand industries in the world, is primarily dependent on the non-metal slaked lime or carbon hydroxide with water. Non-hydraulic cement is formed when, in the presence of carbon dioxide, it hardens due to calcification and calcium oxide is produced. The calcium oxide mixes with water to produce slaked lime. Excess water evaporates by the process of setting and carbonation starts, which requires air. On the other hand, hydraulic cement is formed by the mixture of oxides and silicates of four main substances, namely brown millerite, sellite, belite, and alite. Chemical industry. Non-metals are largely used in the chemical industry. Based on the huge variety of properties displayed, they may be used in chemical industries to serve life sciences, specialty chemicals, and consumer products. These are all important products in the world converted to a usable state by chemical industries that use the natural non-metallic substances. Building stones. Stones and rocks are used for the construction of buildings and roads. They have high density and can provide protection. Bricks, which are made from compression with high pressure, are also used for construction purposes. Based on the material being used, the properties and hence the uses also differ. Gemstones. Non-metallic substances are used as gemstones, which can be divided into precious and semi-precious categories. These categories are based on their rarity, beauty, and value. Although these are natural substances, synthesis of minerals leads to the formation of the gemstones. This includes the identification of the basic mineral or substance of the stone, synthesis from commonly available substance, and finally, after producing a microcrystalline substance, helps in growing the substance. Elements in non-metals used in various industries. Non-metallic substances are used in different industries for their varied properties. Since the compositions of the non-metals vary so hugely, their properties too are very different and varied. Accordingly, their utility in different industries vary. Different non-metallic minerals are used widely in different industries like refractory, fertilizer, cement, chemical industry, construction, gemstone industry, etc. Refractory. For refractory, non-metals which are stable in the face of high temperature are used. Oxides like magnesia, silica, and alumina are the most common materials which are used in the manufacturing of refractory. Fire clays and calcium oxide or lime are also widely used for this purpose. Materials are chosen based on the kind of temperature they will be subjected to. Zirconia is known for being able to withstand high temperature. Graphite too can withstand severe conditions but must not come in contact with oxygen. Boron nitride or tungsten carbide are binary compounds used in this industry. Several other compounds are used based on their melting point. Fertilizer. Fertilizers have high mineral content. The minerals used in the fertilizers are non-metals such as nitrogen, phosphorus, potassium, and sulfur. There are other non-metallic nutrients that are incorporated in the manufacturing process of fertilizers. These non-metals have the capacity to provide necessary nutrients to the plants directly or indirectly. They have the capability to form compounds with each other, like sulfur with nitrogen and phosphorus. Cement. Cement industry's primary components are non-metallic minerals. Non-hydraulic cement, like slaked limes, need air and cannot be used underwater. Lime calcinations take place and calcium oxide, when mixed with water, produces slaked lime. Hydraulic cements, on the other hand, are composed of the mixtures of oxides and silicates. The four major components are alite, belite, brown millerite, and sellite. The mechanical properties of the cement develop from the silicates. Chemical industry. Chemical industry largely uses non-metallic substances to serve different other industries and production units. These include consumer products, pharmaceutical industry, life sciences, specialty chemicals, petroleum, food processing, glass, ink, paint, and adhesive. The different substances used in the different departments and products are nitrous oxide, acetyl, oxygen, nitrogen for industrial gases, vanillin, coumarin, benzyl benzoate for fragrances and flavors, nitroglycerin, nitrocellulose, ammonium nitrate for explosives, herbicides, insecticides for agrochemicals, frit, silica bricks for ceramics, ammonia, nitric acid, sulfuric acid, sodium hydroxide, and chlorine for inorganic industries. Construction. Several non-metallic substances are used for construction purposes. Bricks are used for constructions. These may be clay, concrete, lime, or other binders. Sand is a natural substance used with lime and cement. Stones and rock structures like marbles and granites are used for construction purposes. Slate and limestone are also commonly used rocks and stones for construction purposes. Gemstone. Non-metallic substances are very common in the jewelry and gem industry. The most common and precious stone is diamond, which is formed from pure carbon. Sapphire and ruby are formed from alumina of slight impurity. Emerald, another well-known gem, is formed from a complex composition of silica, alumina, and beryllia. Several other precious and semi-precious substances are used in the gem industry. Types of non-metallic substances. Non-metallic substances cannot exist freely in the substance. They exist in the form of ores or rocks. Based on the source of formation, non-metallic rocks can be broadly categorized into three divisions: igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks. This kind of rock is formed from magma below the surface of the earth, about 50 to 700 kilometers in the mantle of the earth. This is deposited either below the surface of the earth in the form of intrusion or after erosion on the surface of the earth. It is then called lava. There are also pyroclastic rocks or ashes. Since intrusions take a longer time to cool than lava does, they are generally coarser grained. The special characteristic of igneous rocks is that the texture displayed is that of interlocking crystals to give great strength to the rocks that do not weather. Hence, they can be used in the form of large blocks, example, armor stone in coastal defenses. With the help of a wide range of surface and subsurface processes, it is possible to alter igneous rocks and produce a large variety of non-metallic minerals like perlite from rhyolites or china clay from granites. Sedimentary rocks. These are formed from the deposition or sedimentation of particles that are born from the erosion of pre-existing rocks or stones on the floor of seas or lakes. These are consolidated by pressure from the rock particles that are deposited later to form solid rocks. That is why the typical structure of sedimentary rocks is bedded as a result of the layers of sediments. Skeletons and shells or animals also accumulate on the sea floor to contribute to the production of sedimentary rocks. Coal, from which we also get diamond, is formed when plant materials undergo anaerobic accumulation in non-marine swamps and then buried and compressed by the weight of further deposits. Evaporate is formed when sea and lake water evaporates continuously until the salts precipitate onto the bed of the lake or sea. Metamorphic rocks. These are formed from pre-existing rocks, whether sedimentary or igneous. They are formed by the application of pressure and heat. The heat is sometimes provided by the igneous intrusions. If the rocks are buried too deep in the earth's crust by its movements, lithostatic pressure is increased. Some minerals undergo chemical and physical metamorphism or changes to either form new minerals or to recrystallize the existing minerals. Limestone metamorphoses to crystalline marble where the size of calcite crystal grains is increased. On the other hand, clay minerals on shale can orientate to form slate with cleavage. Sometimes gemstones are formed, like topaz, rubies, or sapphires from aluminium silicate or corundum with impurities. A mass of rock can melt at high temperature or pressure, and the minerals start to segregate, forming genesis. These usually have psi histosity, which are usually an important aspect that is taken into consideration when the rocks are put to different uses. Minerals like gemstones, garnets, etc., can be liberated from the erosion of metamorphic rocks. Industrial uses of natural nonmetallic substances. Nonmetallic substances or minerals obtained from igneous, sedimentary and metamorphic rocks are very important in different industries. Nonmetals are actually a group of rocks and minerals that exist in the nature. They have a wide range of properties, both physical and chemical, because of the huge combinations of complex compositions that they have. Because of these chemical and physical properties, the nonmetals are used extensively. In fact, they are more in demand for their properties rather than their content of metal or minerals. They are much more popular and common than metalliferous minerals or fossil fuels. They are largely in demand in the areas where they are found, as a result of which they usually have high place value and low unit value. Non-metallic minerals are utilized in the industries for a large variety of reasons and purposes. Their use is incorporated in almost every phase of human lives every day. Be it food and food processing industry or building and road construction, paper, plastics, paint or chemicals, non-metals are used everywhere. They usually have their sources distributed widely all over the world, although in different concentrations, with restrictions in the range of occurrence in particular geographic regions. Most of the non-metals are used industrially in the nations where they have their original source, but there has been a significant rise in the international trade of these non-metallic minerals due to their rise in demand. Due to their extensive use in the industries, they are referred to as industrial nonmetals as well, being defined as the rocks and minerals that occur naturally and have high economic value. As they gradually do not occur in pure form, they need to be extracted from their natural sources and then be processed so that they can be utilized for their chemical and physical properties. They are different from fossil fuels like natural gas, coal, or petroleum, and also from the metalliferous minerals, as these have to be smelted to give rise to pure metals. Although gemstones can be categorized separately as materials with high value for the aesthetic beauty, they can be included in the group of non-metallic minerals which are noted for their particular uses. This description of industrial nonmetals also encompasses construction minerals such as sand, gravel, or even crushed aggregates of rocks. Particularly in countries which are highly industrialized, these not only dominate volume but also value of the production of minerals. Industrial nonmetals contribute to 72% of quantity and 40% of the value of world production of minerals apart from gas and oil. Thus, these nonmetals support huge and diversified extractive industries that have global significance. The geological development of all these industrial nonmetals include different processes, whether large scale or small scale. These are occurred from igneous, sedimentary and metamorphic rocks that undergo formation, erosion, weathering and redistribution of these. Thus, after undergoing a lot of processes, both natural as well as those formed by humans, the industrial nonmetallic minerals are obtained and used in different industries for their versatile properties. Conclusion. Now, to round up of all the chapters that we have come across, here are the highlights in brief. Non-metallic substances occur naturally on the surface of the earth. They do not exist in pure form, but need to be extracted from rocks of three kinds: igneous, sedimentary, and metamorphic. They have a wide range of properties. The basic nonmetals are carbon, sulfur, oxygen, phosphorus, hydrogen, selenium, noble gases, and halogens. Physically, these have some common traits. They do not have any luster and have a dull appearance as they are unable to reflect light. They are not sonorous, that is, they are unable to create a resonating sound if they are struck. They are generally transparent or translucent and may in fact exist in the form of gases, liquids, or solids. They are not malleable, that is, they cannot be stretched into wire-like form. They are also not ductile, that is, they cannot be beaten into any shape. These are primarily because they are brittle. When struck, they are usually crushed to pieces. They are unable to conduct either heat or electric energy. These nonmetals also have certain common chemical properties. They usually have 4 to 8 electrons in the outer shells of their atoms. That is why they can readily gain or share their valence electrons. The oxides formed by these are acidic in nature. They are very good as oxidizing agents and they also have high electronegativities in comparison to metals. Non-metallic minerals are often formed from the combinations of these nonmetals and hence these physical and chemical properties culminate together. Often the properties change. So, the chemical and physical properties displayed by the nonmetallic substances are versatile and varied and are henceforth used widely in different industries.